So, first of all, I do with my peers if I was introducing this resource would be bringing in a bowl, as I can see on the left hand side here. I'll ask them what it is, and they'll say a bowl. I say what features has it or what's it look like, and they'll probably say a dome. Then I'll say what characteristics has it. So they'll say we can see the key principles there: a spear-like, no internal support. Then I'll bring in the geodesic dome. They will know what it is because I will have completed it earlier on. But then I'll ask, what are the similarities? And I hope they will say they're spear-like and it has no internal support. And then I'd ask, what is different? So the octagonal plan view, if we look down from it at the top, it's made out of all equilateral triangles. But in that picture, we can't see them that they're all equilateral triangles. So I'll give them the model and I let them play around with it to make sure that they can see that all triangles are equilateral. But then I'll bring in perspective view because we've done this in other topic. So that's how I use that geodesic dome, because it'd be using UDL. So I would have talked about it. I would have got them to make one after this, and I would have brought in one made. So therefore, they're getting all UDL learning, because each student learns differently. So my assessment, my assessment is a summative assessment, which is given a grade, but also includes formative feedback so that they'll know how to get on better in subsequent topics and when they're completing this for their leaving cert or when they're doing notes or revision. So it's just draw a 3-frequency geodesic dome with a plan square of 350 millimeters. The reason why I've picked this question, or I've come up with this question, is that it has all the fundamentals of a geodesic dome with an octahedral. If they're able to complete this question to a high standard, they will know the basics and they'll be able to apply the knowledge they have learned from other topics and this topic to draw that to complete this question. And therefore, when they're doing other questions that might be slightly different, they'll know the basics and they'll be able to use their conceptual knowledge and spatial skill to be able to understand why the fundamentals work and be able to complete that subsequent question. So this is just a solution. So we can see here, first of all you draw your octagon out from the bottom side. Then you draw an in view and circumscribe the plan view of the tetrahedron, or the in view of the tetrahedron, or not tetrahedron, sorry, octahedral. Then you can bring your bottom triangle into your 3-frequency using your divided line into 3. You bring a point from O, which is the center of the octahedral, out through the frequency domes or frequency triangles, and bring them across to your in view to where they touch the side. Then we rotate where they touch the edge to the center line and bring them across. This is a key aspect of drawing the side, one side of the geodesic dome. So as you can see, then we bring a line out, and where the blue line here touches the side, we bring that straight down. Then to where it touches the rotated line when we bring it across, we draw that out, and where that touches the circumscribed sphere, we draw it up to where it hits the line we've already drawn out, and that's 1 point. So that's how we find our points, and it's the same for the rest. And then the solution then is just bringing all the points back and drawing it in plan, and then bringing it up and being able to draw an elevation. So it has all the fundamentals of the geodesic dome, and if they're able to complete this, they'll be able to complete any question with a geodesic dome.